So welcome again to the Southern IPM Hour. This one is weed specific, so I'm really excited about this one. Weed control in flooded and furrow irrigated rice. So that's the focus of today. And this is presented by the Southern IPM Center, where in this webinar series, we present research, issues, and programs in integrated pest management from the Southern region. And I'm Kayla Watson. I'm the Communication Director for the Southern IPM Center. We are housed at NC State and at UGA with a mission to coordinate IPM across the region. We're also one of 4 regional IPM centers supported by USDA NIFA Crop Protection and Pest Management Regional Coordination Program. So we're glad to be here. We're glad to have this webinar series and have great guests like we have today. Just a couple of announcements for the Southern IPM Center. As a reminder, we are accepting nominations for the Friends of IPM Awards. There are 7 professional categories and 2 student categories. Everything from educators, practitioners, groups, bright idea, communicator, all kinds of different categories that you can have to choose from. And we even have an IPM Hall of Fame category as well. So that deadline for those nominations is coming up on Friday, and we'd love to see as many people get the recognition they deserve that are doing really great work in IPM. So please consider nominating someone that you know for a Friends of IPM Award. And also, the Southern IPM grants are now open. So we have funding of up to $30,000 for projects and up to $40,000 for working groups, and about $250,000 total. So that ends up being about 11 or 12 projects a year. So those grants are open, and that RFA will be open until November 17th. So you've got some time to look at that and find out more information, and I'll put more information about that in the chat. As for the webinar today, this project is an ARDP project, or Applied Research and Development Project, and that's a part of the Crop Protection and Pest Management Program area at USDA NIFA. This talk will be recorded, and that link will be available after the webinar. So if you have any questions for the speaker as we go throughout the talk, we'll be answering those questions at the end. So make sure to type those questions in the Q&A located at the bottom of your Zoom screen. Our speaker today is Tommy Butts. He is an associate professor and extension weed scientist at the University of Arkansas. So welcome, Tommy, and thank you for being with us.
Thanks, Kayla. Appreciate it. Thanks for having me. Let me share my screen real quick here. All right. We all good?
Looks good.
Awesome.
And now I'm going to disappear.
Okay, sounds good. Well, thanks again for having me. And, thanks for those joining live and for those that may be watching at a later date from the recording. But today, like Kayla said, I'm going to be talking about our USDA NIFA funded project, Effective Cultural Strategies and Application Technologies on Weed Control in Flooded and Furrow Irrigated Rice. Got to click on my thing here. So initially, just a little bit of housekeeping stuff I wanted to mention. So this was, again, funded by USDA NIFA through the CPPM program. And it's an applied research and development area, research-led driven project. There were 6 of us PIs on the project. I was the lead PI, along with Jason Norsworthy, Tom Barber, and Jared Hartkey from here at the University of Arkansas, and then also Jason Bond and Hunter Bowman over at Mississippi State University. We had several different objectives, which I'm going to hit on each one today. 3 of them were research-based, and then 1 was more extension outreach focused. So those are the things that the grant was based on, and what I'm going to be talking about today is a general overview. So just a little bit of background as far as weed management in rice and IPM or IWM, integrated weed management. The first thing I wanted to mention was just some of the problematic weeds that we have in rice. And so you can see up here, we have a list of 5 problematic weeds for both flooded rice, which is the vast majority of our rice acres in the Mid-South, but then also furrow irrigated or row rice. And that's a smaller percentage, about 5%, 5 to 10% or so of our acreage over here in the Mid-South. And you can see that our number 1 problematic weed by far, above and beyond everything else, is barnyard grass. So that weed is extremely problematic for us in rice, and we battle it in almost every single acre that we have planted to rice. Now we have several other weed species there like Palmer amaranth and row rice, which is a problem in all of our other crops. When we go to row rice and we don't have a flood as a cultural strategy, it all of a sudden becomes very problematic for us to manage that weed species in rice. And then you can see several others like sedges, weedy rice, things like that are very problematic as well. Now, I always like to say barnyard grass is the number one, and it always likes to be the Ron Burgundy of weeds, in my opinion. It's the big deal, right? It's kind of a big deal when it comes to weed management in rice. So that's kind of what we're going to focus a lot on today is barnyard grass management. Now, a little bit of background on that. This is from a few years worth of herbicide resistance screening of different barnyard grass populations across the state. And you can see here, each figure is a different herbicide and a different class of herbicides or a different WSSA group number. And so you can see we have over 6 different sites of action or 6 WSSA group numbers worth of resistance in the state of Arkansas between propanil, which is a group 5, quinclorac is a group 29, imazethapyr is a group 2, fluoroperoxyfenbenzol is a group 4. The ACCase inhibitors are group 1s, and then clomazone is a group 12 or 13. I can't remember right offhand. But so all of those are different groups of herbicides, and we have resistance confirmed in the state in our barnyard grass species in the counties that are shaded red. So very problematic. Herbicides are still a major option for us to successfully control weeds, but you can see we're losing more and more of those herbicide options due to herbicide resistance. Now, also we did in this survey we conducted a couple years ago, we asked growers and consultants what % of time that they felt they failed to effectively control barnyard grass with their first post-emergence herbicide application. And you can see here we had a range of responses, but the overall average was 44% of the time. So basically, roughly half the time, our growers and consultants were expecting to fail on their barnyard grass control with their first post-emergence application and expect to have to apply more herbicides or do other things. So that's really a poor success rate, and we're in need of alternative strategies to help manage this real problematic weed. Now, in addition to that, when they failed to control it on that first application, we asked how many more applications were required to successfully control that barnyard grass. And the overwhelming response was it takes at least 2 more herbicide applications. And as a result of those total of 3 or 4 herbicide application costs, the average cost to just control barnyard grass and rice was almost $90 an acre. So it is a very expensive, herbicide cost to go after barnyard grass in our rice crop. So it's a very challenging weed to deal with, very expensive weed to deal with. And so we're drastically in need of alternative options. Now, I'm a big sports fanatic, particularly football. I'm a big football fan. So I always like to include analogies or examples to break it down from a football standpoint. So just to emphasize what we're dealing with barnyard grass, particularly on a herbicide resistant standpoint, I have this video. So I'll just show that real briefly. This is what we're dealing with. We've got barnyard grass right there, and we're throwing all of these different herbicides at it. And that weed just keeps on a truck and keeps on a moving, heading to the end zone where it's going to reproduce, produce seed, and we're going to have to deal with it year in and year out because we can't stop it. So this is exactly what we're dealing with from a resistance standpoint in our barnyard grass and our rice acres, and we need to find something else to throw at it to make that tackle. Now, integrated weed management is a big aspect of, a big push from our recommendation standpoint for us to try and attack this problematic weed. And so it's really trying to use a whole lot of different strategies to throw at managing particularly barnyard grass or other weeds. So whether that be, mechanical, cultural, biological, prevention type methods, and including those chemical strategies as well, but in a big program approach. So the best way to kind of describe that is from actually a paper from Liebman, and it was the fact of there's more advantages of combining different weed control methods, i.e. using many little hammers rather than just using one big control strategy or one large hammer, right? We can get a lot more work done, a lot more successful with a whole lot of little hammers than just one big hammer trying to do all of the work on its own. So that's the premise behind integrated weed management. Now, one of those strategies outside of chemical practices that we wanted to look at, particularly in this project that I'm talking about today, is using a cultural control strategy of basically drill row spacing manipulation. So you can see here a couple pictures of looking at a 13 centimeter spacing or 5 inches versus a very wide row type spacing of 38 centimeters or 15-inch spacing. Now, the most common standard spacing we have in rice production is the standard drill width of 7.5 inches. But we wanted to look at a few different options, particularly the 38 centimeter spacing or 15-inch, in the aspect of technology continually is increasing. If we happen to have a precision planter and a precision planting plate that is developed for rice, it may make crop rotation, a whole nother cultural strategy, quite a bit easier with rice and soybeans if we can buy one piece of planting equipment that is precision planting, like a 15-inch planter, and go out and plant both our rice and soybeans just by switching out a plate. But we need to know how that affects our weed management strategies and our agronomics in rice when we're planting at that much wider row spacing. So that was a little bit at why we were going back and forth or testing these different drill row spacings for weed management in rice. Now, the other aspect of this project that you may have gleaned from the title was application technology, and basically looking at nozzle selection and optimization for the chemical parts of this whole program approach, this holistic program approach. And so there's a wide array of things that are, nozzle choice affects when it comes to applications. So a few things I've got on here, in the lower left, you can see how herbicide off-target movement can affect sensitive crops. So we need to more correctly choose nozzles to reduce drift. However, by changing nozzles, we can affect coverage, which you can see in the coverage card pictures there, the top left, when we change droplet size. And so we're playing this balancing act seesaw effect of trying to manage drift, but also maintain our efficacy, our weed control. And so it gets very problematic trying to balance that out. And I've got this video here to emphasize some extreme examples from our applications where we have that XR flat fan, which is an extremely fine spray. We have that gray cloud of fines that are just waiting, for a wind to carry them away and drift off target. Versus if we go to that TTI nozzle, they're much larger droplet sizes. We don't have that gray cloud of driftable fines that can get carried away in the wind and move off target. And so we have a much more, much less drift prone application, but we sacrifice coverage and then probably weed control down the line. So we really wanted to investigate some different application technology aspects as well for maximizing our weed control in these rice production acres. So that kind of concludes the little bit of background I wanted to present for this project. Jumping into the specific aims and talking about our research highlights and then our extension highlights as well from this project. The first specific aim that we had was investigating drill spacing and rice cultivar effect on weed management in flooded rice. So can we choose a more competitive cultivar? Can we manipulate the drill spacing and achieve better weed control in our rice acres? So we looked at that from several different standpoints. I'm not going to deep dive into the materials and methods. I've got the slides on here so you can look at it maybe later if you review the video or something like that. But a few main highlights: we had 7 total site years for this project. 3 locations were in Arkansas. 1 location was in Mississippi. The treatments that we used were 4 drill row spacings. So we kind of talked about them previously, but 13 centimeters or 5 inches up to 38 centimeters or 15 inches. And then that 19 centimeter is our standard, which is 7.5-inch drill spacing. And then in this project, we had 4 different cultivars that we tested. So we had a medium grain inbred, a long grain inbred, a long grain hybrid, and then a full page long grain hybrid. In the Mid-South, we are primarily a long grain rice market. There's a little bit of medium grain grown, but it's relatively a long grain type market here in the Mid-South. We do have a significant portion of the acres that are grown in hybrid now. I think we're over 50 or 60% are now hybrid in the Mid-South, with the remaining being an inbred cultivar. So we do have a mix of all of these grown in the Mid-South, and we wanted to evaluate if there were any differences from that standpoint. The one other note to make too, we did use a herbicide program in this study, but it was a non-commercial type control program. So we only had 2 herbicide applications go out. It was not what a grower would typically use because we wanted to stress the system and be able to actually assess the cultural control practices, right? We didn't want to have just completely clean plots from the herbicide program. So we did use a few herbicides, but it wasn't a commercial program, so we could assess these other strategies. Some data collection. So we did take barnyard grass density assessments at the pre-flood stage, which is when rice is about 5 to 6 leaf. And then also we did panicle density counts at the pre-harvest stage, right before we harvested the plots. We also used a drone or an unmanned aerial system to take some images, and you can see that in the picture in the upper right-hand corner there, to assess canopy coverage. So we took the pictures and then we ran it through a program called Field Analyzer to assess what kind of ground cover we had from the rice crop in each plot. We also had a barnyard grass seed production assessment at the very end where we harvested barnyard grass panicles to assess seed production. And then we also wanted to evaluate what the rice grain yield actually looked like. And I say that we did all of this. I really need to thank, my team in advance too. So I had a graduate student, a master's student that did a lot of work on this, Noah Reed. He's currently writing up his master's thesis right now. So he did a bulk of this work, but also a big thank you to a lot of my program associates and technicians for helping conduct all this research as well and present a lot of these findings at different meetings and things like that too. So I had a lot of help along the way to be able to conduct this research. Now, jumping right into the results, because that's always where I feel, we get the most bang for our buck. When we looked at the pre-harvest panicle counts, so I'm skipping over the pre-flood. A lot of the trends were the same for pre-flood as pre-harvest. So just looking at pre-harvest for the time slot today, you could see we had a significant row width effect. And so it acted like we kind of would expect, right? As we increased that row width, as we got to, if we went from 5 inches up to that 15-inch spacing, we saw an increase in barnyard grass density as well as the number of panicles present, right? So that 38 centimeter or 15-inch row spacing had a significant increase in in barnyard grass panicles present compared to both our 5-inch spacing and our 7.5-inch standard spacing. We also actually, interestingly enough, had a cultivar response when it comes to barnyard grass panicle counts as well. And so you'll notice the CLM04 and the CLL16 had significantly increased barnyard grass panicles compared to the other two. And if you don't remember what the difference is between those is the medium grain and that CLL16 are both inbred cultivars, and that RT7301 and RT7521 are both hybrid cultivars. And so those hybrids have some pretty extensive growth characteristics. They like to tiller. They have a much higher tillering capacity than our inbreds. And so it seems like that those high growth characteristics were actually able to aid us in weed suppression, right? And seed production reductions, which is really, really cool. Now, there is a trade-off in the fact that hybrid seed is significantly more expensive than inbred seed. We do have reduced seeding rates there, but there would be an economics approach that needs to be looked at to see if the weed suppression we're seeing would follow through economically for growers to choose that higher costing seed. But it is at least interesting enough to know that those hybrid cultivars were able to help in our weed management efforts more than our inbred cultivars. Now, I always like to show a couple pictures at least just to help emphasize that I'm not a complete liar. And so here's a picture from one of our studies at that pre-harvest interval, looking at our standard 19 centimeter or 7.5-inch spacing versus that 38 centimeter spacing or 15-inch row width. And you can see in this image the significant amount more barnyard grass that's in that wider row spacing. You can actually even still see, you can kind of see through that canopy still, right? There's a little bit less canopy coverage. That rice wasn't able to completely canopy over like it is in that 7.5-inch spacing. So anytime you can't get complete canopy coverage, there's more opportunities for weeds to emerge and thrive and everything else. So you can see we did struggle more in that wider row spacing with our weed control. When we look at barnyard grass seed production, so before we were looking at panicle counts, now we're looking at actual seed production. We didn't have a significant effect for row width, but the trend was the exact same. So it wasn't technically significant, but you can see we had an average number, more of barnyard grass seed produced in the wider drill spacings compared to the narrower spacings. And we saw the same effect then on cultivar, though, that was significant, where our hybrid cultivars actually reduced barnyard grass seed production compared to our inbred cultivar counterparts. So again, just to kind of summarize there, it would seem like, trying to do a narrower row spacing with a hybrid cultivar would improve our weed control capabilities from a cultural standpoint. Now, where some of this gets a little bit interesting, though, on the rice side of things, if we look at rice canopy coverage at pre-flood, so we're talking 5 to 6 leaf rice, it really follows what we would expect as far as a trend goes. So again, the narrow row spacing had much more canopy coverage than our wider row spacings. We covered that ground a little bit better. We had less open space. On the cultivar standpoint, it kind of followed the trend of our hybrids had quicker growth and more vigorous growth and more tillering capacity right at that point immediately. And so they had a higher percent canopy coverage than our medium grain in particular, which is a little bit more slow growing, a little bit lower in stature. What's interesting, though, is by the time we get to panicle differentiation, which is a few weeks after flooding, it's basically when the rice is for sure full-blown reproductive mode, so we're done with putting on vegetative parts of the plant. We actually were able to catch up a fair amount with both our cultivars as far as canopy coverage, but also the row width made up a big difference. Now, the 38 centimeter or 15-inch spacing still did have statistically less canopy coverage than our other row widths, but you can see that it was able to recover quite a bit and honestly cover most of that ground similar to the other drill spacings. So, we do see a slight impact on canopy coverage, particularly early, but by the time we're getting to reproductive stages, it really does recover quite a bit and has tillered enough to cover a lot of that ground, even in those wide spacings of 15 inches, which is pretty neat. And then what's interesting is when we look at rice yield, cultivar, which is the graph on the right, the orange bars, looked exactly like we'd expect. The hybrid cultivars do have a higher yield potential normally, and so they did out yield our inbred cultivars. So it just kind of followed the trend, what we would expect as far as what these cultivars would normally yield, right? But what was really interesting was on the row width side, there was no statistical difference amongst our row widths as far as the rice yield coming out of it. So this really shows that 15-inch spacing or 38 centimeters from an agronomic standpoint is highly feasible for growing rice because we maintained our yield, right? And we maintained canopy coverage by the time we got to reproductive stages for the most part. So from an agronomic standpoint, it may seem like that is really feasible if we wanted to try and enhance our crop rotation capabilities, but we are going to have some additional weed management efforts, particularly from a seed bank management standpoint for future years. So agronomically, it's looking like there's some good options there from those wider, or a good opportunity from those wider spacings, but definitely going to need to look at additional strategies, which may add to the weed management costs, and the economics may not end up completely working out in our favor. But so general conclusions from that specific aim was, again, it seems like if we really want to focus on weed management, narrower row widths and hybrid cultivars were the most successful at helping minimize density of barnyard grass as well as reduce seed production, which is a big deal for long-term seed bank management from an IWM approach. So that was the first specific aim. Like I mentioned, that was row spacing and cultivar. The second specific aim that I'm going to jump into now was actually, again, looking at the drill spacing impact for rice on weed control, but then evaluating nozzle type selection, so application technology for its impact on spray coverage, but then also the resulting weed control across these different drill spacings, and seeing if we can optimize which nozzle we should select to improve our weed control. Now, again, materials and methods I'm not going to spend a lot of time on. a lot of this is very similar to the previous specific aim we just talked about. The drill row spacings are the same, the site years are the same, all that kind of stuff. The difference here is that the subplot factor, rather than having cultivars like we had in our previous aim, it's now nozzle type. So we tested 5 different nozzles, the XR, the AIXR, and the TTI nozzles. Those were all single fan nozzles. And then we also tested the AI-TTJ60 and the TTI-60, which are actually dual fan nozzles. So they have 2 exit orifices for spray to come out at angles to try and improve coverage. And so we wanted to evaluate whether there was, a difference with any of these nozzles, and whether dual fan nozzles maybe are worth a little bit of added money to improve coverage and improve weed control compared to just a standard single fan type nozzle. Again, also we did, we were using nozzles here, so we were applying a chemical control program, but it was not a commercial standard. It was definitely a reduced herbicide program to make sure we could still evaluate the drill row spacing effect. Same data collection. There's nothing different here. Again, barnyard grass density assessments at the pre-flood stage, and then panicle density counts at the pre-harvest stage. We took drone imagery, again, to assess canopy coverage, barnyard grass seed production assessments, and rough rice grain yield. The different data collection that we had in this project was actually from the spray standpoint, though. So we used water sensitive cards, which you can see a couple examples of here in the upper right-hand corner. And so we placed 1 card per plot. It was horizontally at the top of the rice canopy, which was about 15 centimeters from the soil surface. And we collected these at the pre-flood application timing. And then we analyzed these cards using deposit scan from the USDA ARS. And so we were able to extract coverage data, so what the percent coverage is on those cards, as well as the number of spray deposits on each card. So kind of like the deposition number, how many droplets were we able to hit that target. So we got those different data variables from those cards. We also conducted an experiment in the lab to evaluate the droplet size emitted from each of those nozzles. And so we used an Oxford laser VisiSize system, which you can see in the lower right picture there. And what this system does is it uses a laser backlight, and it takes sequential pictures within like 10 microseconds apart. And so it's able then to, with taking these pictures, measure individual droplets for their size and their velocity. So we ended up measuring 2,500 individual droplets per replicate, and we repeated it 3 times for each nozzle. So we ended up measuring 7,500 individual spray droplets for every nozzle. And then from those individual droplet measurements, we were able to calculate a DV10, DV50, and DV90, which are the droplet diameters, in which 10, 50, and 90% of the spray volume are contained in droplets of that size or smaller. And then we also calculated a driftable fines, which is the percent spray volume contained in droplets less than 200 microns in size. Basically, if it's smaller than 200 microns, it's a highly drift prone. So we wanted to know what percentage of the spray was in that size to know how much of it was highly driftable. So those were the measurements we got out of that lab experiment to basically assess what droplet sizes we were dealing with from those nozzles. Now, this is a breakdown of those results from that droplet size experiment. And there's a lot going on here, and I'm not going to deep dive into it too much. But the main things that I'd like you to take away are that the TTI nozzle by far had our largest droplet size. So this DV50, or I always consider it the average droplet size, was over 730 microns in size. It was an ultra coarse spray, so very large. We dropped down to the TTI 60, which is a dual fan nozzle kind of version of that. So it had a slightly smaller size from that dual fan, but still an ultra coarse spray. Then our next nozzle was the AI-TTJ, which was a dual fan as well. We dropped down to 440 microns in size for an average size, which was a very coarse spray. The AIXR was even smaller at that. It was down to 300 microns and a coarse spray. And then our very smallest spray was the XR nozzle, which was 116 microns. This is that nozzle we saw in that slow motion video earlier, where it had a lot of that drift cloud in the background. So again, you can see very small droplet size, 160 microns. It was considered a fine spray. And if we actually looked at driftable fines, that XR, about 67% of that spray was less than 200 microns. So roughly speaking, we consider about 2/3 of that application to be highly drift prone. Whereas if we go up to that largest size, that TTI, we're talking somewhere less than 3% of that spray we consider highly drift prone. So you can see a major difference in the potential for drift from these nozzles, as well as a major potential for differences in spray coverage when we're talking about these much larger droplets, and there's a whole lot less number of droplets available in a fixed spray volume. So it's kind of important to remember that the TTI is the largest, the XR is the smallest, and the other three are kind of intermingled in the middle as far as droplet size goes. Now I wanted to look at quick a graph of the spray number of deposits. So those yellow water sensitive cards that we collected during the application, we analyzed them for coverage and for number of deposits, and that's what this data is showing. Now I did also include at the top of each one of these bars is that average droplet size we just talked about for each nozzle, because it kind of plays into this conversation of deposits and droplet size, and then also single fan nozzles versus dual fan nozzles. So what you'll take away from this, again, if you look here, the TTI nozzle, which was our largest droplet size, right, had 730 micron average size. We had the lowest number of deposits on that card. So the lowest coverage or the lowest number of droplets actually hitting the target because our droplet size was so large. You know, vice versa, we talked about that XR. It had the smallest droplet size, so highly drift prone, but we had a whole lot of droplets available for compaction or impaction on those leaves that we can be retained and hopefully improve our weed control, right? So we had our greatest number of deposits on that spray card from that nozzle that had the lowest droplet size. But what's interesting to note in here is if we look at, first of all, the AITTJ versus the AIXR, so this was a dual fan versus a single fan. The AITTJ had a average droplet size of 440 microns versus 300 microns on the AIXR. So it actually had a bigger droplet size, but it had an increased number of deposits on that sensitive card. So what that indicates is that dual fan nature of that nozzle actually may be improving our coverage or our number of droplets hitting the target, right? Because we had a larger size, we'd expect less droplets to be hitting that target, but we actually saw an increase in droplets hitting the target. So the dual fan may be aiding us in that. And we can actually also see that with the TTI 60 over here. So if you look at the TTI 60, it had a 600 micron droplet size, almost double that of this AIXR at 300, but it had statistically the same number of droplets hitting the target. So again, those dual fans may be definitely improving our number of deposits or number of droplets hitting the target, even with larger droplet sizes, which in turn should help us mitigate some risk as far as weed control goes. The more droplets we can hit to the target, the better off from a herbicide standpoint we are of hopefully improving our weed control. Now, I also want you to take note, just kind of remember this trend that you see here. So we start here, we go down, and then we pop back up, this kind of inverse parabola, because that trend's going to come through in the next couple slides as well. And so I just want you to remember that trend a little bit on this slide. Now, getting out of those types of things, so the droplet size and the coverage, actually getting to the meat and potatoes of this, looking at the weed control aspects. If we look at our pre-harvest panicle counts again from barnyard grass, you'll notice our drill row spacing had a very similar result to our specific aim. The wider drill row spacings resulted in more barnyard grass panicles being there, right? So we lost weed control when we went to those wider row spacings. When we look at our nozzle types, you'll see we didn't have a lot of statistical difference here, but across these nozzles, the XR flat fan did have reduced barnyard grass panicles in the plot, likely a result of that improved coverage and number of droplets hitting the target, right? So we were able to improve those number of droplets, which maximize that weed control. And so we reduced those panicles available in that plot compared to the other nozzles. But what's interesting is, at least if you look at the trend line, maybe not the statistical line, but the trend line, again, kind of mirrors in an inverse fashion what we just observed previously on this deposition slide. right? So as our deposition decreased, we actually saw an increased number of panicles. And when our deposition increased, we saw a reduction in those barnyard grass panicles. So this is really interesting that our weed control data was at least, inversely mirroring what we were seeing from those deposition numbers. Now, it didn't necessarily come through statistically, but numerically or visually, it's kind of mirroring those results, which is really interesting. When we look at the barnyard grass seed production, again, we see basically the same trends, right? So with drill row spacing there on the left, the blue bars, as we increased our row spacing, we also increased the amount of barnyard grass seed that was produced. So the narrower spacings were doing a better job at reducing seed production from those barnyard grass plants. And then if we look at the nozzle types, now it wasn't statistical, there was not a statistical difference here. There was some, variability in the data. But if you look at these means, once again, you see that inverse pattern with deposition that we talked about on that slide. And so you can see that as we had reduced deposition, we had an increase in the mean seed production from like the TTI. Whereas in the XR, where we had the highest deposition, we saw the lowest mean for barnyard grass seed production. So again, not necessarily statistical. It may be not quite enough of an effect in these studies to really see it fully form as far as the effect of nozzle type on our resulting weed control. But the trends definitely follow that exact trend we saw in the deposition, that if we can increase that deposition, we're definitely improving our weed control through reduced densities and also reduced barnyard grass seed production, which is pretty cool. So again, just to emphasize, we have this opposite trend, right, where we had low deposition compared to, and we ended up with higher barnyard grass seed production. So just wanted to emphasize those trends almost inversely mirror each other, which is pretty cool. Now, once again, though, similar to specific aim 1, when it comes to the rice side of things, we saw much less of an impact from our treatments. So when it comes to panicle differentiation, canopy coverage, so this is when we're going into reproductive stages in rice, you'll see that row spacing, we did lose a little bit of canopy coverage from that widest row spacing, the 38 centimeters or 15 inches. But generally, it was able to catch up and cover most of the ground similar to the other reduced drill row spacing. So it can make up a lot of ground, even in that wide row spacing. And then from a nozzle impact, we saw very little impact on the rice canopy coverage from the herbicides applied. And from even though there may have been some slight, increases in barnyard grass densities, the rice was able to maintain about the same level of canopy development across those nozzle treatments. And then once again, when we got to rough rice yield, we saw no statistical differences for either treatment, whether it be the different row spacings or the nozzle types used. So again, agronomically speaking, from a rice yield standpoint, it seems like we could get away with a lot of different practices to maximize our rice yield, or at least maintain our rice yield. But if we look at weed control from a long-term standpoint, particularly from the seed bank management type of things, we really have to implement some of these other strategies so we're not battling year in and year out a bigger and bigger growing population out there. So we may not see it in year 1 or year 2 or year 3 from a rice, yield standpoint, but long-term, when we continually have returning seed to the seed bank, that's where this is going to be a problem long-term by trying to use wider row spacings or not selecting the most optimum nozzle type. So again, it's kind of one of the summaries out of this was, again, the same for drill row spacing as the previous specific aim. Narrow row spacings help us aid in barnyard grass or weed management. We can get away with some wider row spacings agronomically, but would have to implement some additional weed management tactics. And then as far as the nozzle goes, it really just reemphasized the point that nozzle selection is important, because nozzle selection influences a whole variety of things like droplet size, spray drift potential, the flow rate, the spray pattern, the compatibility with adjuvants and formulations, spray coverage, and then like we showed in this study, it can impact weed control as well. So nozzle selection is definitely important. And there was some indication that those dual fans may actually help us in certain situations to improve number of deposits and then improve our weed control as well compared to some of those single fan counterparts. Now jumping into specific aim 3. this was, again, another research part of this where we looked at bed width, so the spacing between furrows, as well as the drill spacing effect, again, on weed management. But this was in furrow-irrigated rice or row rice. This has been on the rise in the Mid-South. We're up to 15% or so, especially in Arkansas, is grown in a furrow-irrigated setting versus flooded. So we wanted to look at how these different practices would change in that kind of environmental setting. Again, very similar materials and methods. The only differences here are we only had 5 site years. The study was not conducted in Mississippi. And then rather than cultivars or nozzles, our other effect was bed widths, or those furrow spacings. And so we had a 76 centimeter or a 30-inch spacing, a 96 or a 38-inch spacing, and then 152 centimeter or a 60-inch spacing for these furrows, trying to look at maybe how this water management might impact our weed control. The other couple interesting notes here, again, not a commercial herbicide program, so we could evaluate these cultural practices. But also the way we planted this was we planted the rice flat. So we planted it first, and then we actually pulled the furrows after we planted. So we potentially flung some seed and flung some soil up on top of our beds, on top of rice that was already planted. So that's a very common practice here as well, to plant furrow irrigated rice, is to plant it flat and then pull the furrows. And so I just wanted to mention that that was part of our practice as well. Data collection was exactly the same, so I'm not going to cover all of this again. I mean, again, density assessments, yield, drone imagery for canopy coverage, all of that kind of stuff. So now jumping into the results, we do have a little bit of final analysis to still conduct on this project. The other two are relatively finalized. This one we're still finalizing to some extent. So we wanted to show a little bit more specific, site-specific information from this project at this time. So each one of these figures, you can see each graph is a different bed width. And then within each graph is the different row spacings. So the upper left graph is the 30-inch bed width or furrow spacing. This is the 38-inch furrow spacing, and this is the 60-inch furrow spacing. And then obviously 13 through 38 centimeter drill spacings that we were using for the actual rice drill widths, rice row widths. The main thing to point out here is really that we see a very similar trend when we're at our narrow row spacings as far as our pre-harvest panicle counts. Wider spacings, wider drill row spacings resulted in an increase in our barnyard grass panicle counts. What's interesting to note is what we're generally seeing when we get to these wider bed widths. So the water is getting farther and farther apart, from each other when we're trying to run this water down the furrows. We actually almost see less of an impact of this drill row spacing. So if we're not successfully managing our water, or it's taking longer for water to kind of wick to the center of our beds, we're actually seeing that the drill row spacing doesn't impact our weed control as much anymore. And so we're getting more weed flushes just because we don't have that water there to either aid with it or help our rice grow more competitively, right? Our rice may be struggling to grow as competitively, and so we're seeing less of an impact on that barnyard grass seed production in these wider furrow spacings. It's just, they're kind of all increased basically. If we look at canopy coverage in these different treatments, at the pre-flood stage, we didn't see an effect from the canopy development at a bed width effect, but we did see a drill spacing effect, again, kind of similar to our other projects where we saw an increase with reduced drill row spacings, our rice canopy quicker. Again, what was interesting though, and this one actually was statistically not different, once we got to reproductive, all of these row spacings were able to basically recover and have the same canopy coverage. So early on, we see a difference in canopy coverage from, narrower spacings can canopy, but by the time we're getting to reproductive, all of these row spacings are able to recover and get about equal canopy coverage. When we looked at rice yield from this project, again, very highly variable results. And this may be an aspect to a little bit of our planting method where we had, we pulled the furrows after, so we had some reduced rice stand there and covered up some other seeds and delayed emergence, things like that. There may be some variables there in row rice that just affect, that add confounding effects to these variables. But again, at the Lone Oak site across both years, we had no statistical differences across our bed widths. And then at Pine Tree, a different location, we had variable results where the different bed widths resulted in different responses as far as yield. So highly variable responses, whether bed width was affecting our overall rough rice yield at the end of the day. And then if we look across drill row spacings, again, relatively variable responses. We did see in Lone Oak where the widest row spacing did have some reduced rough rice yield compared to the other ones. At Pine Tree, again, highly variable results. There wasn't really a predictable nature on what our yield was going to do in the different drill row spacings. So the conclusions from this in a row rice standpoint is, again, the narrower spacings seem to help with our weed control aspects. But when it comes to canopy coverage or rough rice yield, it seems highly variable that there's other things affecting it more than our drill spacing or our bed width. And so it's difficult to predict. So again, variable results on the row rice side of things. And it may just be a factor of that being a very different growing production system. Now, just to help emphasize all of this, again, from a football standpoint, I always, again, like to bring this all back around. So this is kind of the research summary to me as far as the need to implement other strategies. So here you can see if we're only using one mode of action, we're going to throw into triple coverage of herbicide selection pressure and miss our wide open successful weed control. If we're only using herbicides and nothing else, we're going to overshoot our successful weed control as well and develop herbicide resistance, which is going to be a major problem for us. And then if we continue to repeat failed strategies, we continue to throw the ball down here in the red zone, weeds will adapt, intercept that ball, and just cause problems for us all over the place. So it's really important to mix up what we're doing as far as management tactics, use different strategies, use different herbicides as well, all of these aspects, and don't repeat failed strategies to improve our weed control long term. Now, really briefly, just wanted to hit on our specific aim number 4 too, and some of our extension outreach outputs that we were able to do, the education aspects. One of the main things that we were able to do during the life of this project was generate the sports weed control extension campaign that this project really, drove a lot into on some of these different aspects. And so this is just a helpful memory aid or acronym to remember our most recommended weed control type strategies. And we developed this poster and actually handed this poster out to over 250 retailers and individuals across Arkansas over the past couple of years. But basically, it's, if you can remember sports, you remember our recommendations. So it's start clean, use pre-emergence herbicides or residuals, overlap those residuals, don't rely just on post-emergence products, required integrated weed management tactics and multiple of them. So things like the crop rotation we mentioned today, seed prevention, row width manipulation, all of these things are needed in this holistic program approach. Being timely is very important with all of these weed management efforts we're using. And then again, selection of multiple effective site of action herbicides. So not just the same one over and over again. So using this holistic approach or this sports campaign can really improve our weed control efforts from an IWM or an IPM approach. Also, we've had a lot of other information we've generated. We have a herbicide resistance trait guide where we talk about rice as well and the different herbicide traits and what herbicides can be sprayed in those. We've talked about Palmer amaranth, and we mentioned at the beginning how difficult that is in row rice acres with no flood or cultural practice to manage that. So we talk in this publication a little bit about trying to manipulate other strategies to manage Palmer amaranth and row rice. Our MP44 provides a lot of different recommendations as far as not only herbicides, but nozzle selection and other aspects for weed control. And so we've put a lot of information into this as well. And then a few other more specific things. The QR code can take you to a field day video that we did a couple years ago, highlighting part of this project as well. We have a texting service to try and reach stakeholders directly, and we've passed some of this information on directly to them through the texting service. And all you have to do is text weeds, so the word weeds, to that number 501-300-8883, and you'll get text messages right on your phone from us. That's just updates on what's going on in the weed science world and some recommendations for different IPM approaches in weed management. And then also we have our Weeds Are Wild podcast series, which we've been doing for 3 years now. This is available in multiple different places, Apple Podcasts, Google Podcasts, on our website, all those kinds of things. We actually had a specific project where my master student joined me for an episode, and we discussed his projects and some of these results as well. So a lot of good IPM information from a weed control standpoint in our podcast that we do every year as well. Just a few other real quick outputs. We had about 12 different presentations on these projects that occurred over the past couple of years at several different meetings, including the Southern Weeds meeting, the Weed Science Society of America annual meeting, the Rice Technical Working Group, Sarah 18 group, and then also our Arkansas Crop Protection Association meeting. We published several public research reports that are available online regarding this research through our Arkansas BR Wells research series reports. We also developed a significant amount of personnel with these projects between grad students, postdocs, program associates, and then as well as several of us faculty. And so, we trained a lot of people on sound research and data collection, rice agronomy, as well as weed science, and especially in this integrated pest management or integrated weed management approach to this rice weed control strategy. And then just a final couple things as far as that are still in development. So my master student is finishing up this fall. So he's got his thesis that is getting ready, finalized here. And as a part of that thesis, he's going to have 3 different journal publications that'll get submitted to weed technology or pest management science out of this project as well. So a lot of good outputs that were created from this project. As far as project outcomes and some public value things, we were actually able to talk about these projects in a couple of different field days, but one in particular was the University of Arkansas Pine Bluff, which is an 1890 land grant university. We were able to talk about it at that field day with a lot of underrepresented groups within the ag industry, and approximately 120 people were in attendance to learn about this IPM approach in that setting. So that was really good. We were able to form a lot of these different recommendations for these IWM tactics and be able to pass that out through the different methods I talked to you about before, as well as consider profitability as a standpoint, right? So the 7.5-inch spacing seems to work for us a great deal. So it's not like we're trying to recommend going from 7.5-inch spacing to 5-inch spacing, because economically it just doesn't make sense to have to buy a whole new piece of equipment. Even if we do slightly improve our weed control in some aspects, it doesn't make sense for a grower to have to buy a whole new brand piece of equipment for just a slight increase. We did, again, develop through some discussions with USA Rice and other groups and some press releases and things about this project. We're able to develop a positive public perception around implementing some integrated weed management strategies outside of just herbicides, as well as increase awareness of what we're trying to do for rice sustainability in the U.S. and improve our rice export markets. So we're trying to do a few things there with USA Rice. And then also we aided in the creation of a knowledgeable and competitive workforce between the students, postdocs, county extension agents that we trained through several trainings as well on this project. There was a lot of different things that we were able to do to help both individualized people, but also the public as well. So with that, the final takeaway, my final football reference for the day, if I can tell you anything that, for successful winning weed control is to do this. Everything does start with a strong residual program up front, but we need those integrated weed management tactics to carry us all the way, to do the jukes and the jives, to add all of those different strategies and make it all the way to the end zone, as well as some of these other guys downfield doing some blocking, like starting clean and being timely. All of these things working together in a holistic approach, which is really what IPM is all about, is what we need to have winning weed control long-term. So I couldn't find a better example than that right there to highlight what IPM is all about, particularly integrated weed management in a weed science world. So there's that. With that, big thank you to all our funders and particular USDA NIFA and our award number you can see there. Several other sponsors that were crucial to help with this project and others. And then as well, I also have to give another big thank you to my weed science team for all their hard work and efforts as well. And with that, I'll conclude my talking portion here. So big thank you for joining me today or listening to the video later on. And here's my contact info. If you need to, ever want to get a hold of me, feel free to get a hold of me either by giving me a call, shoot me an email, anything else. I'd love to hear from you. So with that, again, thank you very much. And hopefully I got a couple minutes for questions at least.
Yeah, so thank you. Great talk, great takeaways. The question that we have in the chat is that first, great use of football for explaining the strategies. Have you found this to be effective for communicating weed control concepts with growers? So using those metaphors and things like that.
Yeah. So I've been in Arkansas for 5 years now. And so I had a mentor, and I'll shout out to him, Sean Conley, up at the University of Wisconsin-Madison. He told me a while back, I think when I was doing my master's degree up there, that when you're given extension talks, it's always great to form something that year in and year out people can look forward to and have like as a memory aid. And so I've always enjoyed sports. And so that I took that to heart. And that's kind of what I started down here. My very first year was just start working in these sports metaphors and things like that. And I can tell you every year now, when I go to my winter production meetings, people are very excited to see what kind of sports thing I'm bringing in or sports video clip I'm bringing up this year. And I've been able to tie in some really good examples. I think like that last one was the last example I used there was the one I did last year. And I mean, it ties everything together, especially in an IPM approach, really well, of everybody working together and all these tools that need to work together to be effective. And so, yeah, it seems like it's gone over really well. People look forward to seeing what I'm coming up with next. And it seems like people remember it a lot easier than if it's just me talking from a soapbox. So it's gone really well, I think.
Yeah, definitely. And it helps to really help those complex things stay with somebody that's a little bit simpler to remember too. Yeah. So that's awesome. One last question for you, Tommy, before we go today. Was there a piece of data that was most helpful from your research moving forward?
So that's a great question. With these specific projects, I honestly think, I don't know if there's one that I could name as more important than the other. I think they all help tell the entire story, right? So, I think the density counts and the panicle counts are really important to kind of know how these strategies impacted that. But I think then you need to have the seed production at the end of it. When we're talking IPM, we're really talking long-term approaches to weed management. And if you're not affecting seed production, then at the end of the day, it probably doesn't matter a whole lot, right? You want to know that you're also reducing what kind of seed is getting returned to the seed bank. So that was important to me. In the nozzle study, the coverage and droplet size stuff really helps tells the story a whole lot better on why we're seeing differences in weed control across nozzle types. So I think that was important. And then looking at the rice canopy coverage and how well rice is able to recover, even with some increased weeds or wider row spacings, and how much it can still maintain yield across those environments was really important to say, listen, down the road, if this technology is available, it's very feasible. You just may have to look at extra weed control efforts, and maybe the crop rotation ability, is going to help aid in that too, long-term, from multiple rotation standpoints. I don't know. But so I think all of those really played a role in being able to tell the complete story. The one thing I would like to almost take the next step on this that I think is missing from all of this is a true economics analysis, right? Putting the money to all of this on how much extra does the hybrid seed cost, and does that make up for, the reduced weed seed that we see? If you had to buy a new piece of equipment to do this strategy, how long would it be until you got your return on investment? Things like that. I think we've got the base level here, but that would really take all of this to the whole next step too for a grower.
Definitely, that economics piece is crucial, because so many folks need to know how their money is being spent and if it's worthwhile for them. So that's absolutely right.
Well, and really too, I mean, when we're talking about IPM, to me, that's the biggest selling point, is trying to convince people that the reason for it is because long-term you're going to see that much better ROI. And so having that piece of data would overemphasize all of these points and help show the importance of IPM even more than what we can show just with reductions in seed production and density and all of those other things.
Absolutely. Well, thank you again, Tommy, for this presentation. Thank you for all your hard work in this project. I think you got some good yield and good results from this. So thanks for all your hard work, and thanks for everything that you do for IPM.
No, thank you. And again, thank you for having me. And again, if anybody ever has any questions, feel free to get a hold of me.
All right. Well, thank you. And if you want to find out any more information about the Southern IPM Center, I just want to remind you that our website is southernipm.org. So thanks so much for attending today, and we'll see you next time.